All right, let's get started with code signal, shall we? And then one thing you want to do is that whenever you're trying to go to code signal, I would suggest just Googling it because it's just impossible to go into the arcade section from the codesignal.com page. So I would just do like code signal arcade and then just click on this link basically. So the full link is app.codesignal.com/arcade. Then we can just go into the intro section, right? So we're just going to be solving the 60 questions, and you can, use your Google account to log in or use your username password. That's also works, but I just used my Google account to log in. Okay, so before we begin, a few things to warn you about code signal, right? So even though this has 60 questions, you cannot jump into any of the questions. So it is locked, right? So you can only solve one at a time. Basically, you cannot jump forward to the questions. You have to solve it and then go to the next one. And the second thing is that it's not structured by difficulty or by topics. So you have to keep that in mind. I mean, it is generally getting harder as you go on, but still, like even on like the 7th problem or in the 8th problem, there's like a really, really difficult problem. So just keep that in mind as we move on. Okay, so let's just begin. And the first problem should be really, really easy. The first few problems actually. So let's just do the top. That's fine. Okay, cool. And then we're going to be using Python as our language, right? So where's Python? Here we go. Okay, cool. So the first question is just basically saying you have two parameters and then return the sum of the parameters, right? So this is pretty simple. So we just see one param1 plus param2, and then just return statement, right? So this is like the simplest problem that it gets. Then we could just run the tests, and then control enter is like the shortcut to run the tests, and then submit is what? Control Alt Enter, okay? Let's just do Control Alt Enter to submit. Okay, there we go. Then we can just continue. All right, so let's go to the next question. And then it says, okay, so we have to find the century from the given year. Okay, so basically the idea is divide by 100 and then get like the whole division number, like the integer portion of it, right? So, but that works except on the these cases. So, for example, like if I say 1905, that's like the floor division would be 19, and then I have to add plus to it, right? Plus 1 to it, right? And that's how you get the 20th century. But as soon as you go into the 100th division, then that's the edge case, right? So basically, what I have to do is like year divided by 100. If it's equal to 0, then if it's exactly divisible by 100, right? So I have to return year divided by 100. So that's the answer. And then otherwise, you can just return year divided by 100 plus 1. So let's just run the tests. And then you can submit it too. Okay, so before submitting it, there is like a shortcut in Python that you can do with like one line. So I'll just show that. You don't really have to do this. You only do that once you get used to Python. So I would not recommend this solution for beginners at all. It just makes it really, really confusing. So essentially, like instead of writing this one, right, you can write this instead. So return year divided by 100 if year remainder is 0, else year divided by 100 plus 1. So basically, if you want to read this, it's just like this. Okay, if this is true, then return this. Otherwise, return that. So that's the idea. So let's just try and test that. Yeah, that works. Okay, let's just submit the solution, and then that works too. Okay. Cool. All right, check palindrome. Okay, so check palindrome, true or false. Okay, so basically, palindrome is like whenever you reverse a string, and then if it's the same as reading it from the backwards or from the front, if it's the same, then that's a palindrome, right? So you can check the definition of palindrome here also. So there is like a really, really easy solution in Python, which, it is not really optimal, but it is like really, really good to know. So the idea is you check like if input string is equal to the reversed one, right? So you have reversed string. So there's like a shortcut to reverse in Python. So that's like colon -1. So I would just, advise you guys to just memorize this thing. So this what it does is just basically reverse the string, and that's it. So now if that's the case, then return true, and then otherwise it's return false, right? But this is a really bad practice to do this, because this thing is already a Boolean, right? So you don't have to really return true and return false, but this just so it shows like a really bad practice coding style. So instead of that, you just do it with one line, which is like that. The output already expects a Boolean, so this will return a Boolean. So it just matches that. Okay, now this works. But this is like a really bad solution, right? Yeah, the reason why it's bad is because you are making a copy of your original input. So which means like the space complexity would be O of n and the time complexity of O of n. But technically, what you can do is like check the beginning and end and then go until the middle, right? So you just check the edges and then go inside one by one and then check those strings, go and then meet in the middle, right? And then you don't have to check all the strings essentially. So let's just comment this out and then let's do the solution with 2 pointers. So essentially that you have a left pointer and then right pointer, which is the input string length -1. So the idea is you have 2 pointers, left, right, and then whenever right is greater than left, you're just going to do while loop, right? And then we just check if, input string of left is not equal to input string of right, then return false, right? So that's the exit condition essentially, like if it's false. Then if it's true, then we just basically move the strings, not strings, but sorry, the pointers one by one until they meet in the middle. And then if that's all true, and then if it skips all this, then that means it's a palindrome, right? So let's just try this solution. Okay, that's good. Let's just submit it. Okay, cool. So essentially, like this solution is like the best solution out there to check this palindrome or not. So it's really, really efficient. It doesn't require any extra space, and then it meets in the middle. So it's really efficient in terms of speed too. So I would recommend this solution to check the palindrome. Okay, let's just go to the next one. Okay, cool. What does it say? Given the array of integers, return the pair of adjacent elements that has the largest product and return the product. Okay, so essentially, you just check every adjacent elements and then max. Let's just do like max prod, right? So the initial value of max prod is really, really important actually. So what I would recommend is doing like the initial number, right? So basically, like let's just assume the first two are like the maximum, right? And then if that's not the max, we just update the max basically. And then we can do for loop until the end of the array. I guess we can do -1 because we're checking the next one, right? So we can just say, okay, max prod is equal to whatever the maximum of max prod and the product of the adjacent ones, right? So input array of I times input array I plus 1, right? And then we just return the max prod. Okay, so it's pretty simple. And then this one is not using any additional space, right? So the time complexity would be just O of n of time complexity, and there's no space complexity, no additional space complexity. So I'm just gonna submit that. Okay, that's good. Pretty simple problem. Okay, shape area. What is this? Okay, yeah, I think I remember this one. I think it's better to show some drawings in here to show how it works. Okay, let's just I just open Paint, right, and then I'll just copy this thing. All right, so basically the question is asking, okay, find the area of this blue area, right? Find the area. So essentially, if it's 1, then it's 1. If it's 2, then it's like 5, right? And then if it's 3, I think the answer is 13. I think, yeah, okay, 13. And then this one would be like 25, I think. Yeah, that would be 25. So basically, that just return that number, like the area. So to do this problem, there's like a trick, right? So once you could like test the first initial numbers, then you will see like a pattern. Like it's almost, you can actually kind of like see it and feel it. But the pattern is basically just, I'll just do this, then it will make sense. Okay, so let's just try to find the area now. So basically, like the area of this n equals 4 is what? The area of the red ones plus the area of the blue ones, right? So that's the area. So how do you find the red area, right? So that's actually like n minus 1. So it's like 3 by 3, right? So it's 9. And the 4 is like the edge blue ones is like 4 by 4, right? So that's like n squared. So that's the idea. Like n squared plus n minus 1 squared would give you the total area. So let's just code that up real quick. Essentially like n times n squared n minus 1 times that. So that's the answer. Okay, that's it. All right, I think once you get used to the patterns, it just makes it really, really, really easy. And doing this if the for loop is just pretty bad, I would not suggest that solution. So essentially like 1 plus 3 plus 5 plus 7 plus 5, it's not gonna get you anywhere. I mean, of course it will give you a solution, but I would not recommend it. This solution is like the best one. But of course, if you didn't find a pattern, then I would just, use the loop to sum it, but still, this one is good. Okay, cool. And then shape area, make array consecutive to. Okay, what is this? Ratio or got status statues, okay, of different sizes as present. And as present from Codemaster on his birthday. Okay. All right. Oh, bigger than the... Okay, I think I understand the question now. Okay. So basically the idea is that you have a bunch of like statues and you can think of them as like heights, right? Height of the statues. And basically you want the statues so that if you rearrange them from the minimum until the maximum, there can be like no gaps, right? So essentially like the answer is 3 because there are like 3 gaps in the middle. So you have 2, 3, and then you're missing 4, 5, and then you have 6, and then you are missing 7, and then 8, right? So you're missing 4, 5, and 7, which is 3 statues that you're missing. And then just have to return like how many statues are missing in order to fill the gap. So essentially what you do is like maximum statues would be 8, right? And then that's how many statues that you want to fill. But we also have to find the minimum, right? So with like below the minimum, we don't need it. It's from the minimum until maximum. So we can just subtract the minimum. And then what you can do is minus the length of the statues, because that's how many statues that we currently have, right? We just have to find the missing ones. But I think there might be like plus or minus 1 error in here. So let's just check, right? So 8 minus 2 is 6. 6 minus 4 is 2, right? So we have to add 1. This is because whenever you count like, hey, how many numbers are between 2 and 8? It's actually what? There are 7 numbers, right? So how you do that is it's 8 minus 2 plus 1 because you're counting one of the edges extra, right? So that's why you can add 1 to it. So that's the add plus 1 here. And of course, you can find the minimum and maximum by just one loop. So this solution would use like 2 loops, right, in Python. But, I mean, that's pretty straightforward. So let's just keep with the solution. Then we can, if it's really, really necessary, we can always change it. But you still have to understand that's what's happening behind the scenes. Okay, cool. Almost increasing sequence. Okay, what is this? Given a sequence of integers as an array, determine whether it's possible to obtain a strictly increasing sequence by removing one or no more than one element from the array. Okay, no more than one element. Okay, so what does that mean? I guess you can delete one number and then check if the number is like strictly increasing. Okay, so basically like in this problem, like whichever number you can delete, it's not going to be strictly increasing, right? So that's like not possible. Like it's just not possible. But in here, you can delete 2 and then these 2 would be strictly increasing. So that's why it returns true. Okay. So I think that's the question. So basically, at most you can delete one. So you can, leave the list as it is, and then if it's a strictly increasing, then that's great, right? So you don't have to delete anything. So I think this is one of the problems that just got significantly harder to solve, actually. Yeah. So as you can see, like the dislike count is like 5,000 versus 3 and 2,000, right? So people didn't like it because this is like significantly harder than the previous ones. And I'm not sure if there's like a really easy way of doing this. Of course, there's like an n squared of way in doing this, which is just remove every number, try every number, removing it, and then if that doesn't work, then just return false, right? So that's gonna be like n squared, trying every number. But there is like a O(n) solution. I would think. Of course, there is. I think. But let me see. So it's strictly increasing. I guess there is one solution where it's kind of like a trick. So you go scan from left to right. So 1, 3, okay, it is increasing, and then you immediately go down, right? So it's like 3, 2. Okay, so it's down. And then at this point, there's like two ways of doing it. So one would be, okay, let's just delete 3 and then keep on going and see if that works. If not, then it's false, right? No. If not, then we can delete the right one and then see if that works. And then we can just keep on going, basically. So you have two places that you can basically try to remove, and then that's going to be your suspicious like two numbers, right? So you can just check those, and I think that should be fine. So that solution definitely works, and I think there's no other easy solution than this one. If you want to do it with O(n), that is, but if O(n) squared, then definitely it is possible. I'm just wondering how should I code it. Is increasing. So there is a way of doing it with like O(n) space too. So basically, you can actually like remove the item from the list, right? And then scan it. But that will make you we would have to have like a copy of the list. But no, certainly that's not optimal. Like the most optimal would be just ignore this index and then straight jump into here to here, right? So in terms of code, that's kind of complicated to do, but removing this number would be just like the easiest. But that's like I said, it's O(n) time complexity and O(n) space complexity as well, because we're making a new list if we remove it from the middle. Okay, so I think the very optimal solution is going to be really hard to write, actually. There's a lot of edge cases. Okay, let's just try the non-optimal solution first, like the removing one, right? So, like I said, so we can do like for I in range. We just do like n is the sequence of length, okay, and then n minus 1 actually, because we want to check it with the right one, right? So if sequence of I plus 1 is less or equal than sequence of I, which means it's like non-increasing, right? Okay, so that's where we have like the suspicious two indices, like I and I plus 1, either that. Okay. And then we can do like R1. So I'll just say S1. Sequence 1 is going to be, I think I have to copy it and then pop it actually. Okay, so let's copy the sequence first. Okay, so this is how you copy array in Python. So basically, you're just selecting everything from beginning to end, right? So that's how you copy it. And I think there's also a copy method too, but I'm not sure. But this definitely works. So you copy the array first, and then you pop it, right? So pop the ith index. Okay, and then you just do, okay, if it's increasing or not. Okay, so that's the pop version. And I think there should be like a helper method too. So is increasing. Okay, and then we can get an array and then like index, I guess. Let's just do x as an index. And then for I in range starting from x, because we don't want to check everything from the beginning, right? Or I guess do we want to? All right, let's just check everything from the beginning because we're lazy. So for I in range, length of r, and if this happens, right? So basically like this thing happens, then it's false, essentially. Return false, so that's not increasing, right? And then return true in here. Okay, and then what we can do is like, okay, so we have that. Then we have s2.pop I plus 1. Okay, so both of them has to be false in order to be false, right? So you have to check that. So let's just do like answer 1 is equal to is increasing s1. So that's the answer for the first one. And then answer 2 is like is increasing s2. So that's the first two answers, right? So if s1 so if either of them are true, then it's just basically true, right? So or s2, then return true, otherwise return false, and then at the end we can just return true, because if we didn't go to this one, then it's strictly increasing, right? So let's just try this and see if it happens. Oh, it didn't work. Execution error. Did not execute. What? Runtime error. Okay. Probably. So I didn't want to see the error output. Empty. What? Console. Return. I wonder what it is. Okay, let's just try running again. Okay, error output. Okay, here. Oh, index out of range. That's weird. I did say n-1, right? So why would it be out of range? Maybe it's because the input is just... Oh, no, it's not. List index. Oh, it's R. Wait. Yeah, here. This should be -1. Yeah. Okay, there we go. Okay, let's just submit it and see if this works. I'm pretty sure it will. Okay, it does work. Okay, so the this one is not the optimal for sure, because we are copying the list and then popping it, and then we're checking if it's increasing or not, right? But the most optimal solution would be just ignore this index and then check whether it's increasing or not, right? So basically we have to pass in like an index in here, like an x index, and then we skip over that index and then check it, right? So that's how it's supposed to be. But I don't want to spend too much time in here, but I don't think it's really valuable to solve it optimally in here. I think the idea is just really good to have, and that's it. And so we can just move on to the next problem. So yeah, so just have the idea, have it handy, because like if I have time, of course I can solve it. But since we're, if you have 60 problems, then I don't want to spend too much time on this, the first beginning problem. So, I mean, this is one of the good solutions, but it's definitely not the best solution for sure. Okay, let's just move on to the next question. Okay, cool. So what does this say? After becoming famous, CodeBots decided to move into a new building together. Each of the rooms has different cost, and some of them are free, but there are rumors that all the free rooms are haunted. Okay, since the CodeBots are quite superstitious. They refuse to stay in any of the free rooms or any of the rooms below any of the free rooms. Okay, cool. Given matrix, rectangular matrix integers where given represents the cost of room. Yeah, your deck is to return the total sum of the room that is suitable to code bots add up to all the way. Okay, gotcha. All right, so this is, even though it's like a matrix and then it seems like a graph problem, it's not really a graph problem. So basically you just go column by column and then add up all the non-zero values until you hit a 0, and that's it. So essentially you don't add this one because this is below the ghost room, right? So you add this one, this one, this one, and this one. So essentially 1, 1, 2, 5 is like what, 9. Okay, cool. So in kind of like matrix problems, the first thing I do is just basically do like row and column count. So row, col is a matrix of 0, that. And then we go column by column, right? So basically, whenever it's a column, I just call it like the j, and then I would be the row. So for j in range, col. So we're just gonna go column by column, and then this was gonna be the row by row, right? Okay. And then there's gonna be like s equals 0, which is the sum. And then if matrix of I and j is equal to 0, then we essentially go on to the next column, right? So how should I approach this? I think we can just break it, right? Yeah, so we're just gonna say break, which means we're gonna break out of this loop, which means it's gonna go to the next column, right? Okay, cool. And then if that's the case, then break. If not, then basically s equal plus matrix I and j. I think that should work. Let me just try and test it. Okay, yeah, that worked. Awesome. So I guess the most important thing to realize is that you're gonna go loop. You're gonna do the loop column by column, right? So that's why you have the column for loop first, and then I just call it j because I like to call the call the column indices j and then row indices I, because once you access the index, it just goes on as like I and j, right? Which is kind of looks good. So that's why. Let's just submit it. Okay, cool. Oops. Okay, continue on. Let's continue. All right, so that was the first 8 problem, and then let's move on to the smooth sailing part. Okay. Given an array of strings, return another array containing all of its longest strings. Okay, cool. So basically, like we have a bunch of strings, right? And then the length would be 3, right? So the 3 is like this one, and that one. So essentially, we have to calculate the max length first. Let's just assume it's 0, and then for s in input array, then I would have to find like the max length, right? Max length, and then length of s. So that's how you find the maximum length of the list of strings, right? Now you just basically filter it out. So, and then go to the array again, and then resultant array. If length of s is equal max length, then r dot append s. Then we just return r. And that should just work. Okay, yeah. So we just find the maximum length first, and then within that maximum length, you just filter it out using that, right? There is a way to shorten this for loop, but I don't want to really go too much into detail. But in Python, basically, like these kinds of filtering things, it can be done in one line for sure. So I think I can do it here. Let's just comment this on and show you. So I mean, once you get used to it, it's pretty handy. So x, let's just do that for s in input array, if length of s is equal to max length. So okay, I think this should just work. Let me just see. Okay, yeah, it does work. So yeah. So basically, like this thing is exactly the same. And then also, like one neat part about this is that you don't really have to declare a variable, right? So you can just do this instead. So essentially, you have the loop, right? And then this s is just meaning, okay, we're trying to select the s, right? So if I do like times 2, then it will select the s times 2, but we're just selecting s in here. So that's why you have the s, and then looping it, and then what's the condition, right? So this is the condition to filter it out. And then we can just do that, essentially. So it's really handy thing to have, learn. Okay. Common character count, what is it? Okay, so we have 2 strings, output should be 3, y. String have 3 common characters, 2 a's and 1 c, okay. Gotcha, okay. Cool, and then the constraint is lowercase English letters, okay. That's good. All right, so the most optimal thing in here would be to use like hash map approach or like indexing approach, right? So like indexing, what I mean is you get the ASCII number of each of the letters and then put it into like bucket of 26 and then you do that. But hash map approach also works too. So let's just do the hash map approach because that's like the classical one, right? So let's just do map 1 and then loop through each of the characters, right? So for C in S1, C is for character, right? And then map 1 of C plus equal map 1 of C plus 1, right? Okay. So there's a problem here too. So we're just setting map 1 of C plus equal 1, right? So whenever I see a character, then I'm just adding the value on top of that. So that's key is the character and value is like the how many count that we see, right? But in here, there's going to be like a problem with initialization. So that's why we do like get C and then default value is 0. So whenever there's no key, then this will not cause any errors. And then we're just going to copy this over here and then do it with map 2 and S2. Okay. Yep, that one. Okay, cool. Okay, now that we have the counts, then we just basically get the minimums and then return the sum, right? So for key value in map 1, I mean, either map works, but I guess you can technically start off with the smallest map, but I mean, in this case, it doesn't really matter. Maximum size is 26, so it doesn't matter that much. Okay, so now what you do is like is plus equals map 2 dot get key. If it doesn't exist, then we just add basically 0. And then that's like the value of the map 2 character, right? So now we have to take the minimum of this value and then our current value, which is that. Oh yeah, I have to also do dot items because that's how you loop with key value in a dictionary. So which is a map, right? Right, and then you just return s. So that's how you do it. Oh, you didn't pass the oh, what? I think there's. What does the error say? Let me see. Line 4 here. What's the error? Oh yeah, there shouldn't be a plus in here. Yeah. Okay. Yeah. Cool. Yeah, there shouldn't be a plus here. Okay, cool. Yeah, nice. So the another way to do it would be just instead of using map, you can just use like a 26 sized array, right? So that is also a really, really handy trick to have it. Maybe I'll show you next time whenever I see like a dictionary problem, but in here, hash map approach is just fine. Is lucky, okay? What is it? Ticket numbers are usually consist of even number of digits, okay? A ticket number is consistent lucky if the sum of the first half of the digits is equal to the sum of the second half, okay? Given the ticket number n, determine if it's lucky or not, okay? Cool. Cool. All right, so how should I approach this? I think there's like many ways of doing this, but what is the most optimal way? I guess what we can do is like store every digit in an array and then just sum them up, first half versus second half, and then that also works. And that would not cause any like n complexity because the number is basically limited by its length, right? So the larger the n, it's not going to make the runtime as big as that, essentially. Well, it kind of scales, but not necessarily. So the maximum size, if it's 10 to the n, the maximum size of the array is like just 6, right? Compared to like a million, which is, you know, not that much compared. Okay, let's just do that. So let's just do like digits is that. And then let's just do a while loop, n greater than 0. What I can do is digits dot append n divided, get the last digit, right? And then divided by 10, essentially. So you can make this a shortcut like that. And then let's just print out the digits, right? And then see what happens. Then return true, I guess, for now. Let's just print out the digits and see what happens. Okay, so we have input value is that. This is that. I think that works. Okay, that works. The reversed one, you know, it doesn't really matter because we're just going to take the first half and the second half and sum it up. So, right, so the reversing, it doesn't matter. Okay, so S1 is equal to sum of the digits selecting the half. Okay, so I mean, you can do it this way, like array slicing, but this will, you know, create like another copy of the digits, which, you know, might not be optimal, but there's also like index way of approaching this, right, without any extra space complexity. So let's just do that. I in range, length of digits divided by 2. And then S1 is equal to digits of I. And then S2 is actually equal to digits of I plus length of digits divided by 2. I guess we can just, you know, declare a number saying half, right? Half is length of digits divided by 2. Okay, and then use the half here, and then use the half here. Then return S1 equal S2. So if it's equal, then return true. If it's not, then return false. Okay, I think that works. Okay, cool. Let's move on to the next one. Sort by height, okay. Okay, what does it say? Some people are standing in a row in a park. There are trees in between them which cannot be moved. Your task is to rearrange the people by their heights in a non-descending order without moving the trees. People can be very, very tall. Okay. All right, this can be bothersome of a problem. Okay, so I think my idea is that we can filter out the tree heights, not tree heights, sorry, the people heights, like on 50. Oh yeah, that doesn't work because you cannot. Oh wait, does it? Let me see. So we have 190 and it moved to the last one. Okay, so that does work. Okay, so basically like you have heights, which is empty array, and then you're filtering out in the heights first, right? So for h in A, if h is not equal to -1, then heights dot append h, because so those are going to be the heights. And then you do like heights dot sort. Okay, that's how you sort it. And then essentially just go from the beginning, right? So we'll go for the beginning and the length of A, and then if A of I is equal to -1, just basically continue, right? So if it's a tree, then we don't want to edit anything. And then if it's not, then A of I would be your heights of, let's just say J. And then J should be another iterator, which, you know, increases by 0. Initially, it's going to be 0, and then J plus equals 1. And then we can just return the A. Okay, let's just do that. Okay, that works. So essentially the idea is you sort the heights first, right? And then you go through the array and then ignore the negative ones and then just fill out these ones from the sorted array, okay? And the time complexity and space complexity, I'll just start doing that from now on because it seems like these problems are going to be more meaningful. Space complexity is going to be O of n because we're copying array, right? Then time complexity would be of n log n because we're using sort. All right. I'm pretty sure there is a. Oh, maybe there's not. Let me see. There might be a O of one space complexity solution, but I mean, I don't really encourage that because that's just going to be way, way overcomplicated. Yeah, I don't think that it's worth it at all. There might be, who knows, but I think this is a good solution for sure. All right, let's just submit this. Cool. Okay, reverse in parentheses. I think this is going to be a really hard problem, actually. I think I've seen this before. Write a function that reverses characters in possibly nested parentheses in input string. Input strings will always be well formed within matching s. Okay. So essentially, the problem is asking you to reverse the strings within the parentheses. Like if it's like that, then return this one. And then if it's like that, you have foo, and then reverse this one, and then buzz, right? So the output should be foo stays the same, and then we reverse it, and then buzz. And then there can be like nested loop and nested parentheses, right? So foo, and then this will be reversed, and then this will be reversed again. So it's going to be quite complicated to solve this problem. And the initial idea is just to use recursion, actually, and then just recurse the string, and then yeah, but it still is going to be difficult, even if we use recursion, because you have problem within problems, right? So that means it's just basically default recursion. Let me see. This might take a while, but so you can do. So this problem is already getting the input string. So I don't think there needs to be a helper function because we can just return the function by itself. Okay, so for I think so. Let's just create an array, and then basically you just add character by character, and then join them. Join them together, right? So the idea would be return that essentially. But you have to add character by character, right? So for C in input string, then if C is equal to, that's not equal to, I guess, so does not equal to beginning parentheses, then we can just append the character as it is. Okay, so that's like the easiest case. So we can just append. But whenever I see a beginning characters, then that means we begin the recursion, right? So elif C is equal to, oh wait, sorry, yeah. I think, so this should be else then, okay, else. Oh wait, then I'm forgetting this closed parentheses part, okay. What should I do then? Okay, maybe there should be like this part, and then this part, and then finally that part. Okay, let's just do that. So basically you do, if it's a beginning array, then you do recurse, right? And then if it's like a closing parenthesis, you do like reverse, because whenever I see this thing, that means we reverse this whole thing beginning until the end, right? So that's why I'm just trying to do that. Okay, cool. Okay, so let's do the reverse part then. So we are reversing from the beginning, I think. So essentially you have, we want to reverse this whole array like from the beginning. Okay, I think that's pretty simple, which is r equal to r like that. But we can optimize this further again, but let's just do this reverse thing real quick and then see if this works. And then if it works, maybe we can optimize it further. But for now, we just basically reverse it whenever there's a closing parenthesis, right? So you have to think about it like this. there would be no opening parentheses in this case, right? So basically, whenever you call the recursion, then it will start like this, and then you keep on adding it, and then you encounter this one, and then you have to reverse it, essentially. All right, okay. And then in here, what you do is return the current array. So you have the array that is going on, and then plus here, right? So this thing. So basically a plus solution input string of. I guess we need to have the index in here. So enumerate I plus 1 until the end. Okay. So I think this should work. Let me just check real quick. Oh, it doesn't work. Input string return value. So for bar, so this thing didn't work. Okay, some of the tests actually did work then. Okay, so there's only one test that didn't work. Okay, so the first parentheses one, it does work. Okay, with one parenthesis, it's just working fine. Okay, so empty string works fine. This one works fine. This one works. So this test form must be the nested one. Okay, but the nested one, it didn't work. Let me check. Okay, it's really hard to keep track of this. Let's just copy this. Okay, so that was the input. And then my return value was this thing. Okay, so we have foo, bar, buzz, blim. So it didn't reverse at all. Okay, let's just check. We have, or maybe whenever it encounters that. Okay, so we encounter this one, and then we recurse, right? So we recurse until we have this one, and then just recurse that whole thing. Then it keeps on adding. Keeps on adding, and then it recurses again. Okay, so it does not keep track of what is reversing, I guess. Okay, that's a problem. Okay, so essentially, like, we have this one, and then we encounter this, and then this plus that is returned, and then we just add this one straight up without reversing, and then this one also without reversing, and then we encounter this thing here, which is, you know, it's we didn't even reverse 2, I guess. Okay, that's pretty bad. How should I approach this? Whenever there's a parenthesis problem, it's usually like a stack solution that is present, but I'm not sure if stack would be necessary here. So we have open this one, and then reverse here, open this one, reverse here, and then cut. I guess there might be like a really good stack solution instead of recursion, but I mean recursion will work for sure. But it's just that my recursive solution is not doing what it should. Okay, maybe there's like a. Okay, hold on. We can just reverse this thing then. If it's open up, then we have to reverse it. Okay, then that might be it. Okay, so I think in Python, reversing a string is also, we can just do this. Let's just try that. Oh, it didn't work. Let me see. Return value. So whenever there's a closing ones, okay, so we have reversed the whole thing. Okay, so yeah, reversing the whole thing doesn't make sense actually. Yeah, bar. Yeah, reversing the whole thing doesn't make sense. You just have to reverse it until that point. Yeah, so that doesn't make sense. Okay, so we have returning this thing. The problem is that we don't know in this like end parentheses. I guess using a stack might be a clever way than using recursion. So let's just think. So we have this thing. Stack it, stack it. So you open the stack, add it, and then open the stack again, but we have one stack though, and then reverse it until maybe you keep the indices of the opening parentheses. Okay, maybe. Okay, so you add the indices whenever there's open parentheses, and then you keep on doing that. Nah, that doesn't work. I don't think, at least. So you have this, that, reverse it until. Okay, let's just try that. Let's just comment the solution out. Let's just try with the stack. So a stack for C in input array, right? Oh, input string, okay. Input string, and then essentially let's just do like answer is an empty string for now. And then if C is equal to opening parentheses, we do something. Elif C is closing parentheses, we do something. And then else, I think we can just append the C on top of it. Right? Okay, so if it's opening parentheses, we add the index, I guess. So let's just try that. Enumerate. Okay, so we add I. And whenever there is a closing parentheses, we pop like top stack.pop. Okay, so that's gonna give us the most recent index, right? And then, but that doesn't. Okay, so I cannot just add this to the answer though. I have to empty the stack. Or maybe index and a string. Okay, yeah, this is getting way more complicated than I thought, which hopefully I can solve it in a few minutes, but we'll see. I'm getting stuck for sure. Okay, so we have closing parentheses, which, I can definitely reverse the indices. But even if I reverse it and then add it to something, I have to store it somewhere. And then whenever there's like another parentheses, then I have to reverse that again. I mean, that's why the recursion solution is so good though. But maybe the stack should contain some sort of like string too. Stack. So you have open parentheses and then add, closing, reverse. Then you add. Okay, you know what? I think I know something. So let's just start with that, and then I guess -1 dot append. Okay, this might just work. Let's just assume like the stack has the empty string, right? And then instead of answer, we're just gonna add it to the top of the stack. Basically, stack. Does that work? Let me see. Yeah, I think that should work. Stack of -1, that's the top, plus minus plus equal C. Okay. Okay, so that's gonna be the stack, and then whenever there's a beginning character, then I would be adding a new character on top of it, right? And then whenever there's a closing parentheses, then I would pop that and then insert it back to the stack. Right? Or not? Let me see. Yeah. Insert it. So you popped up for top one. Not insert, I guess. So you have, maybe it's like this. Top like that. And then let's just print the stack. Return join stack. Okay, it didn't work. Let me see. Where's console output? Oh, okay. Bar wrap. It almost worked. So why is it? Oh yeah, right. I think we should add the small, empty string in here. Not. Okay, yeah, that worked. Nice. Cool. Okay. Let's just submit this and see if this works. Nice. Cool. Got it. All right. So I guess I should explain this a bit further. So the idea is that you have a stack. This can be like list of lists for optimal solution too, but I mean, whatever. We're just gonna do it with a list of strings. The idea is that whenever there's like a beginning parentheses, right, you add like empty string like this. And then whenever you see a close parentheses, basically you keep on accumulating the strings, right? And then you reverse this thing, right? So basically you pop it, basically remove this thing, okay, pop it, and then you reverse it, and then modify it in here. So basically this should be, so I popped it here and then add it to the FDAS. So you reverse it and then add it to the top of the stack. So that's why this is here. And then, whenever there's non-parenthesis character, just add it to the top of the stack. So basically if it's like that, then you add characters here. So they just keep on going like that. So I think that's like really intuitive solution. And I think, whenever there's a parenthesis, there's a good chance of using stacks. So let's just keep that in mind. So I think this is a good solution. In terms of complexity, this might be like really complex. Let me see. It just depends on number of parentheses, actually. So if there's n string and n parentheses, it could technically be, you're just going to keep on reversing, right? So if there's n, and then each reverse is going to be O of n, so n squared, I guess. So yeah, I think so. So time complexity is n squared, and the space complexity would be O of n, because the stack can be as big as the string, right? But also like I'm using string to add this, but instead of strings, it can be like I said, list of lists, which will give you an optimal solution in terms of big O of n. So that's what that would be my answer. Okay, so let's just keep exploring the waters. Okay, well, finally we just finished 13 problem, and then I think this should be it for part 1. So we just solved the first 13 problems in under 60 minutes essentially, and then we're just gonna go on to the next part, which is starting from 14 and so on until 60. So I'll try to make these videos like 60 minutes at a time. So that's all. All right. Let me know if you have any questions, and keep the comments, like, and subscribe, and I'll see you guys in part 2.